First, the radius is about 1,000 meters, and the velocity of the car is 72 kilometers per hour, and the width of the road is 40 meters. Yeah. So the problem is what's the height difference between between each side of the road. Okay. Okay. Maybe some difference between our textbook, but that's okay. Yeah. So this problem is how can we design a road and use the height difference to make the car can turn left without friction. Yeah, that's the problem. Yeah. So first we will do some analyze on the okay. So first we have to draw the free body diagram. We know that the car will the gravitational force act on the car. Yeah. And the next is the normal force of the road. So we can get the total force on the axis. Okay, so we can get a free body diagram. So the force acting on the car, the x-axis is the n sine theta. Okay, and that will provide the centripetal force. So we can calculate by the FAC. And the other one is the y-axis. We can see that the normal force will get equal to the gravitational force. So the n cosine theta equals to the gravitational force. And we can do some easy calculation. We can divide it by 2 sides. So we can get that. Tangent theta is equal to the g centripetal acceleration. Yeah. So we can get the speed. But you have to be careful because this is not the SI unit, so you can still transfer to 20 meters per second. Okay. So we can get the equation of acceleration. This is r and the velocity squared. Okay, so we can get the okay. So the g is 10 meters per second squared, and then the radius is 1,000. Okay, and then the velocity is 20 squared. Okay, so finally we can get the result is the okay. So that's the tangent theta, and we know that tangent theta is the width of the road. Use an L to the H. So we can get that is the L and the H. So we can get the L here. So we can get that L is 40. So the height difference between two sides is the 1.6 meter here. Okay. Any question? And since I just discussed with some Japanese teacher, they told me that the grade 1 in Japan still is the introduction for physics. So I know maybe you are. Do you know the centripetal acceleration equation? Any of you? I just explained them that in Japan they still not study the circular motion. Yeah, but I accept the centripetal acceleration means the 向心力. Okay. So do you study the circular motion before? Any of you? No. No. Okay. Thank you. Yeah. It's okay. This is the most difficult in this class, in this part. Okay. And the second one, yeah. I just want to show you that this is our normal class in our daily life. Okay. And the other one is if we don't have a slope, we just use the friction to provide the centripetal force. How can we calculate? Yeah. So I will do another explanation. Okay. The other one is okay. So did you finish? Okay. Yeah. So let's keep up. Okay. So the other one is a car in the. Sorry. I want to remove it. Okay. So if we had a car here, and the car is here. This is the Lamborghini, okay? Yeah, and they are going turn right, okay? Okay. Yeah. So first we have to draw the free body diagram. So first this is the gravitational force, and another one is the normal force. This is the friction force here. So we can get the equations X on the car. Yeah. This is a horizontal direction. Will provide the centripetal force and is normal force equals to gravitational force. Okay, and we know that if so the least steady friction is equal. The normal force and the constant of the friction. Okay. Yeah. So let's do the same deal to divide it here, and then we get the result here. So the normal force and the mass. Yeah. So finally. And you just calculate that before. This is 10 and 1 solid, and this is 20 squared. And the left, this is the same as the tangent theta. Did you remember? This is the same as the proper one. Okay, this is interesting in that. Okay, so this is some practice in the real calculation, in the real situation in our daily life. If the car will turn around, we need the friction, and technically, if the road cannot provide enough friction, what will happen? Anyone can answer me? Wow. That's a lot. What happened? Please, can you tell me what will happen? If the road cannot provide enough friction, what will happen? If you will go out. Okay. The car will not, it will keep going straight. And in Chinese we call that 雷惨, okay? Okay. Yeah, so sorry. I said the Taiwanese, right? Sorry, yeah, okay. So we will finish the section here, and then we will do some